Huh? There's got to be a better way. Thanks, bud. Good morning.
Morning.
Good morning. Third time's a charm. Good morning. If you're sitting in the middle, I hope you brought an umbrella. Sorry for the roof. Beware. I hope you had a nice weekend. I sure did. We've got a special item on the agenda today. If you check your email, you should have a message from Dr. Brookstein with a link into it to a survey. And we're going to start today by asking you to reflect on how the class is working for you so far. We are about 4 weeks in now. We've completed our first major module, and this is your chance to shape your destiny a bit. So I'm going to give you 6 minutes here, and if you take that time to log in, if you brought your device, you can do this on a phone, you can do it on anything that talks to the internet. We'll be back with you in about 6 minutes here. I only have a 2-minute timer, so I'm going to do 3 of them. Thank you for your honest and, in case you're worried, completely anonymous feedback. Oh, that time I printed something with a staple and then stapled it. That's Monday. That's Monday, huh? You like it? Yeah? Cool. Like the team leads. Let's see, how much longer do we have here? There we go. Another couple minutes here. All right, let's take another couple minutes and then we'll move on, okay? Thanks, everybody. There's outlets? What?
I learned about it last semester. It's a game changer right here.
Yeah. Talk about right tech. That's awesome.
It's just like I saw a friend of mine plug in.
All right, so as we wrap up here, I just want to say thank you for taking the time to give us some feedback. I'm going to be reviewing all of this in the next couple of days. Promise to tell you what it is that I heard, and we'll see how we're doing. If there's anything that needs to be updated, let it be known that we are very open to that. Our mission here is for you to learn as much as humanly possible. So thank you for taking the time to do that. If you haven't finished, the survey will stay open for a little bit longer today, so you'll be able to wrap it up. Okay, so here's where we're at. You should be halfway done with Python tonight, which may seem very scary. If you are looking at the Python HackerRank assignments, what you'll notice is that the questions look very familiar. They're actually the same questions, just in a new language. And so what we're trying to show you, actually let me ask you, why are we already doing a second language? Who has a guess, apart from crime and punishment? Yeah. Because they relate to each other. How so?
I don't know, just kind of like with general stuff like variables, loops, and stuff like that.
So a lot of overlapping concepts. A lot of it works the same way in both languages. That's actually the big point we're trying to drive home. There are two main concepts when you're writing any code. There's the logic or the idea of what you're trying to do, and there's the syntax of actually getting it to do it. The level of depth that we go to in this class with the different concepts are universal. I challenged one of my colleagues the other day, and they came up with 12 languages that they know how to code in, and the 10 skills that we're teaching you here are used in all of them. And so we tried to pick things that are as applicable for you as possible. And so that's why we're picking them. But what we want you to see right away is just how flexible you can be. As soon as you start working in one language, the next one becomes that much easier to learn. As far as where we are in getting things submitted, the class as an average has a 70, so that's pretty great from an administrative standpoint. I'm still on a crusade to get in trouble for everyone having earned an A. I can't wait for that to be the emergency that we have to deal with. So, dial in. Get me the rest of this JavaScript stuff. We definitely have a little bit of a trail, number of students that have completed things. And so we're almost 100 of you, though. Almost 100 of you have a 100% in this class as of today. It's pretty wild. And if that's not you, it is not too late. Join us. Join us. Okay. Secret to coding well is making mistakes and learning from them. I promise that what I'm going to show you today might look a little weird, but I'm actually going to do some coding right in front of you, and I'm going to show you every single mistake that I made while writing this code. And so hopefully that doesn't get us too confused here. The point is, coding, even after you have lots of experience, still looks like mixing Google and some programming window. So that's what we're going to do today. Quick status update. How are you doing on identifying your messes? How's that going? Have you had a chance to talk yet with your group? Have you had a chance to interview anybody yet? Okay. It's going to be all right. I know we're throwing a lot at you. This week's going to be a bit unique. This is the foundation for the semester project. You're going to spend 6 weeks working on this project. And so we want to make sure that you have identified something that is meaningful to you and to the world around you. And so on Wednesday, we're going to do something strange. We're actually going to require attendance. And the reason that we're going to do that on Wednesday is that half of your grade for this week's code sprint is going to come from working through this interview assignment. And we want to make sure that you and your team have a chance to plan that out, have your interviews, and then start to post-process them. And so you're going to have some time on Wednesday to work with your group and some time on Friday to wrap that up. So it doesn't all have to happen outside of class, but you do want to get going. You won't be able to just interview the people in this room and get what you need. So I encourage you to get started on that, but we will give you basically the full session on Wednesday as well. One more time, just to remind you, we are actually going to take attendance and count that towards this week's code sprint. So it's a little weird, but I think it's really important that we solidify our projects before we can move forward. Thanks for that. So who can tell me how these two ideas are related? I'm very comfortable with uncomfortable silences. Maybe you guys want to argue with each other for a minute. How about I give you a minute and you talk with your companies? And then I'll poll you guys for a couple of questions. So let's take 1 minute. It is on my watch. Well, I'll watch it, but I'll let you know when you got about 30 seconds left. Let's answer the question. How are these two things related? Forgot to give you this back. You can aim it at the floor until you're done with your conversation. I don't care.
You're on the right track.
All right, 15 more seconds. Morning. All right, who's got it? Somebody's going to get voluntold. What do we got? Difference between conditionals and control flow. Yeah.
Control flow is the proper way to use conditionals.
Ooh, interesting. Control flow is a thing that uses conditionals, maybe even the proper way to use them. What else? Who let all the crickets in? I know it's Monday. Let's drink some coffee. Yeah. Control flow is made out of conditionals. Okay, we're on the right track here. Somebody give me an example of a conditional statement. Yeah. I'm sorry? If. Okay, if what?
If number one is greater than number two.
If number one is greater than number two. So conditionals make comparisons. Things like if. So we can test if a thing is true. Less than, greater than, equal to. There's a lot of options there. Where are some places that we might be interested in making comparisons? Give me an application. I see. Okay, fine.
Yeah, if like your shoe sizes go to this department, if your shoe size this one, go like you have kids and adults department.
Okay, so switching between two departments in a shoe store based on size. Interesting. Okay, I saw a hand over here. It's disappeared. Okay. Somebody out of the middle. I know we're here. Where's a place you might need a conditional? Don't make eye contact with him. Ah.
Programmatically or real life situations?
Either. Programmatically, real life. Yeah, here we go. Based on what the user wants, like a program to do, maybe. Right? Okay, that's actually starting to push into the control flow thing. Great segue, right? Some other places that we might use conditionals beyond just control flows, maybe we want to check if a password matches the right password. Right? We want to check if somebody's name matches in two different entries. Control flow, as you pointed out, uses conditionals to decide where the app's going to go. So if they come into the shoe store, we tell them whether to go to the kids section or the adult section. If they enter the wrong password, we throw one message at them, and if they enter the right password, we throw a different one. And so I thought today that I would give you a bit of a live demo on writing some code that uses these. And the way that I really think about the difference is, once you've gotten to the point where you're using else ifs and elses, where your program itself can do different things, you've really moved into the control flow range. You started toying with this on Friday, writing an app that actually did different things. It was like a text-based menu, right? We hit a 0 and it does one thing, and we type a 1 and it did something else. We're going to unpack some of that today. So I'm actually going to switch over to a text editor here. Bear with me. And show you some stuff. So font test to start. Tell me when you can read this in the back row. We got it? Everybody reads this? Okay, how big was that? 180. We sure we're good? Okay, so quick poll. No right answer here. How many of you at this point have written JavaScript in a text editor and used something like Firefox Developer Edition to test it out? 1, 2, 3, 4, 5. Okay, TAs don't count. Interesting. If you're having trouble, what you're about to watch me do is how I actually learned to code. When you go to the interactive tutorials, when you go to things like our HackerRank assignments, they're relying on some background information that you might not have seen if you haven't tried it this way. So I encourage you all to try this out. This screen that you're looking at here is nothing more than a text editor. I like it because it lets you make a black background, which is easy on the eyes. And in a minute, you're going to see that it actually highlights syntax, which is really helpful. This is called TextMate. I guess they owe me $100 for the endorsement at this point. This window to the side, this is just Firefox Developer Edition. It's a web browser. I can go to a website, and it shows you the internet. The thing that's neat about it is that if you go to the tools and look at the web developer tools, you can pull up what's called the web console. And there's not much to be seen here at the moment, but when you write console.log, that's where it goes. So today what I'm going to do is I've got a website that I created. Let's see, we said 180, there we go. This is a little web page that I wrote in HTML. This is the entire file. You can go on to our Canvas site and download this. And the only thing that you need to be concerned about is this line right here, which says controlflow.js, which is just another text document that in a minute we're going to fill in. And with these three things, all created using nothing more than a text editor, the only difference is instead of saving it as .txt, I saved it as .js or .html. Now this web browser knows how to display it. So this is the world's most simple web page, but this right here, this how control flow works, came from right here. And what's fun about it is I can change it. And if I save this change and I refresh my little website, it's updated. And so once again, I can toggle and I can look at the tools here. Let's see, tools, web developer, and console. And here's our console. And it's angry with me. Is this font readable in the back? Thumbs up. Okay. So it's a little angry with me because I didn't tell it what text encoding, but that won't matter for what we're up to. Just ignore that message. Okay. So you should try this. In fact, I would recommend that you do your assignments here and then copy and paste them into HackerRank, because what you'll start to see is what's happening behind the scene. If you're confused on why we use return versus console.log, this is about to show you why. So what I want to do is I want to start by writing the pseudocode for a for-function calculator. I know you've already seen this, and so we can go kind of quickly. We're going to make a for-function calculator. What's the first step if a person is going to use a calculator? Yeah. I'm sorry? Input a number. Okay, so my pseudocode, I'm going to do something like A equals prompt user for a number. Then what do? Somebody from this region. What's the next thing you do when you're using a calculator? You typed in a number, and then you hit an operation. Okay? Operation equals prompt user for operation. And then the last step back here. Yeah. Input another number. Okay? Now what? What's the next thing this thing needs to do? We've got numbers, we've got an operator, yeah.
Test for what operator they use.
We want to test for which operator we're using. So this is where the control flow part of our entire program comes into, because depending on what they typed in for operation, we're going to do something different. And so we could do something like if operation equals a plus, what are we going to do? Add the numbers together. Maybe we'll store it in a variable called result. What if it didn't equal a plus? What's the next question that we could ask? Yeah.
Else if operator equals minus.
All right. Else if operation equals minus, we're going to do the result of A minus B. And we can continue doing this, and it helps if you know how to spell. All right, we could do a multiply. And if we only have one more option, what do we use? Nope. We've got two more options, don't we? We've got multiply and divide here. Are we done? What else could happen? They entered the wrong. What do you mean by the wrong one? Anything besides these. And so we need some sort of an error check, right? Something that says else maybe, I don't know that operation. There's a couple subtleties here that I want to point out to you. Did you notice that I used double quotes here? Challenge. Why did I use double quotes? Back there, yeah. So that I could use the apostrophe in the word don't. JavaScript, some of the languages that we work with, they don't care which you use, but they're looking for pairs of them. And so by using double quotes on the outside, those are actually programming quotes where this is just text. Little hack there to make it work easily. Okay, and so that's basically our code, right? We do that, we've calculated a result, and we're done. What I would like to do now is make this thing a little fancier. Are there any questions? Maybe we want to do one more step, which is like display the result. How about that? It's only useful to them if they can see that result. So I'm going to start by just copying and pasting this. But we're about to add the D and the S button are dangerously close to each other. Ooh, whoopsie. There we go. Okay. What I'm going to do now is I'm going to add some functions. Instead of result being A plus B, I'm going to let result equal the result of another function, my adder of A and B. Now, is this a command that anybody knows right now? Yeah. I'm sorry? I have to write it first. We've got to create it. And so up here in the top of our code is kind of the typical place to do that. We're going to do a function definition that looks something like my adder of A and B. And what does that function do inside if we want a function that adds two numbers and sticks them back in that equation? I see you. Yeah, down here. Returns A plus B. Return A plus B. So let's just track this one for a minute, and then we'll fill the other ones in a little bit more quickly. Okay? Down in the main code, we're going to prompt user for numbers and operations. If we get to the addition operation, we're going to take the values that the user typed in, A and B, and we're going to throw them into this function. Now, inside this function, A and B are added together, and the function says, okay, I'm done with those, and I'm going to spit them out as a return. That puts that number right here on this side of the equal sign and sticks it into the value of result. Why on earth would I want to do that? There's much more, yeah. Because I could use it somewhere else, right? That function is now portable and could be used in other places in my code. Certainly. We're going to get to that in a minute. What else? Yeah. Oh, if I wanted to add features. What if we wanted to create a single addition function that knew how to handle more than one number? We could write a function that if it sees 2 numbers, it does this. If it sees 6 numbers, it does something else. Maybe we wanted to write a code that is smart enough that if I give it single numbers, it knows how to add them. But if I give it arrays, it knows how to add them. All of this keeps things nice and simple because that would all be buried in the myAdder. So we could come in here and do the same thing for subtraction. My subtraction of A and B, and copy and paste our function prototype. Yep, there we go. Our function definition here. My subtraction minus my multiply, my divide, how's that? What could go wrong with my code at this point? Yeah. I'm sorry? It may stop because I have return. So when we get inside a function, we run that function until we hit the word return. And at that point, whatever value is next to that return gets tossed back into the rest of our code, which is all down here, which we often call the main part of the code. And so whatever happened in here now stops, and we jump back out here. This is one of the little nuances that you might not have caught yet when you're working with HackerRank. When you're writing functions in HackerRank, you're always living in this world. We've written this for you. And so often what we're going to ask you to do is return a number, and we'll call the display prompt down here. Okay. What else could go wrong with my code? Yeah. If b equals 0, we have a problem. Take a minute with your group and figure out the pseudocode to make this function a little bit more interesting so that it can now handle the divide by 0 error. 1 minute, go. All right, so what do we do if we discover we've divided by 0? What do we do if we've divided by 0? Oh, sorry. Hey.
Inside the division operation, just have a statement checking for if the 0.
So check if there's a 0 or not, right? We want an if-else statement in here to stop the divide by 0 problem. And then, depending on the calculator you use, different things happen. Let's just return an error. So what we could do, for example, is we could say if b is 0, return now what? Okay, else return a divided by b. And now we've just made a little bit smarter thing, and we haven't messed with the main part of our code here that does it. Looks like translating this into JavaScript might happen next time, but we'll finish the pseudocode today. So one reason that we used functional code is so that we can add features. The other reason somebody pointed out was so that we could reuse a bit of code. Right now, our calculator is fairly stupid in that it only knows 4 functions. What if I wanted my calculator to be able to do an exponential? How would I do that? Mumble, mumble, mumble. Somebody back here? How would we do that? Yeah. Same way, right? And what would be the operator that we'd use? The star star, the double star is how we do that, say in JavaScript. Let's imagine for a moment a world where JavaScript doesn't know that command. We're going to write it ourselves. Okay? So it sees that. If this were the real world, we'd be able to type something like A star star B, and it knows that means take A to the bth power, right? Let's pretend like it doesn't know how to do that, just like it doesn't know how to say there's an error if you divide A by 0. So we're going to come up here, and we're going to do another functional prototype up here, function definition, my power A B. How might this work? How do you take a number and raise it to a power? Yeah. A loop. Okay. So we want to take a for loop. Did everybody catch that? What we're trying to do, if you want to take a number to a certain power, that's the equivalent of multiplying it by itself so many times, right? If we want to take it to the third power, we'd take that number and multiply it by itself 3 times. Fourth power would be 4 times. That's a candidate for a loop. So maybe we could do something like result equals A. Just start there. But we're not done. Now what we'd want to do is something like for I equals 0, I less than B, I think you said. What would be our incrementation on I? Yeah. By 1, right? So what's the command that gets us I plus 1 equals I? Yeah. I plus plus. And in here, what do we want to do? Yeah. Order of operations? How so? I'm sorry? We would need to multiply before we subtract it. Yes, right. So we're writing a standalone function here that the only thing it knows how to do is that power function. You're right. If we call these in the wrong order, we're going to run into a real hassle. Absolutely. Absolutely. Did I see other hands? Yeah. Okay, so we want to cycle through. What variable do I want to multiply by A at this point? If I wanted to do A squared, what would I do? Now that I've taken and said result is equal to A, what do I do next? Do we need to argue about this for a minute? All right, I'm specifically going to target somebody in the middle of the room in 1 minute. Break off in your teams for a minute. Let's wake up a minute. Let's try and figure out if we're going to multiply, what are we going to do to take this power next? What's the next thing we got to do? Of course, by telling you guys that, you're all going to go to sleep, right? Yeah. I'm sorry? I'm sorry? I is not defined. Okay. Yeah, if this were code, that would matter, but since we're just doing pseudocode right now, we're just getting the logic out of our brains. We'll translate it into language in a minute. But you're right. We'd have to define it. Who's got it? Who's got it? Yeah. Okay. Uh-huh. So we take a variable like c, or some other variable, start it outside the for loop by making it equal to a, and then in the loop, okay, so set it equal to itself times a again. Let's try this out. Why do we need another variable c? Uh-huh.
What it would do is it would do 4 times 4 for the first iteration, which would be 16, which is all good so far. But if you have 8 times a, it would do 16 times 16.
So if we do, okay, so the issue is if we don't declare a new variable, then it's going to keep overwriting itself. It's just going to keep repeating the same command over and over again, which isn't quite what we wanted. You got a hand up over here? Okay, so that was... Now, who would like to, and then what would I do next? If I do this, c equals c times a, inside the loop, that means every single time we go through the loop, we're going to multiply by a again, multiply by a again, multiply by a again. Right? What's that? You wanted me to make it the other way around where a equals a times c. Doesn't matter. Does it? Ooh, weird. What's a way that we could eliminate a variable from this altogether? Just use result. We could make this equal to result, and result. And so now this can just go away because that's just repeated. And return result. We have created ourselves a power function, right? Everybody says yes, right? I have made an error. It's not the kind of error that would throw red text at you. It's the kind of error that's going to give the wrong answer. Yeah. Okay, so if it's raised to 0, we've got an exception to a specific case, right? That's issue number 1. We don't want to multiply this out and get 0. I hadn't even thought of that one. Caught on tape. What else? Yeah. I has to be equal to 1, not 0. Ooh, interesting. All right, grab a piece of paper. Shh. Grab a piece of paper. Down there. Yeah, it's kind of like a backup more than anything. Run my code. If A is equal to 5 and B is equal to 4, give me the result, and along with it, give me all the values of I that happen in this loop. So we can make some sort of a table maybe to keep track of this, right? A is equal to 5. B is equal to 4. In other words, I would like you to do the following command. My power of 5, 4. Run my code.
There's 3 different things you can do. You're not wrong. I'm trying to get all the answers.
Team leads, wave at me when your team has a number. What did we come up with? Who got 625? Couple hands on 625. Who wishes we got 625 but know that that's not what this code currently does? Couple hands. What'd you get? 3125. What'd you get over here? I saw your hand up. 3125. 3125. This code, where's my laser beam? This code right here, run for A equals 5 and B equals 4, gives us 3125. Tell me how. Let's see. We're going to come into this function and we're going to take a value of A and stick it in result. So instantly result has a value of. Then we hit the loop, and the first time through the loop, what's I equal to? 0. And if we do result equals result times A, what's result now equal to? 25, because result currently has a 5 in it. We're going to take A, which is equal to 5. 5 times 5 is 25. Second time through the loop, what's I equal to? 1. And so what's this going to be equal to? 25 times 5, 125. I is equal to 2. 625. I is equal to 3. What's that one? Grumble, grumble. I know I got one more minute. 3125, 3125. And then finally it's equal to 4, which causes this true false to switch, and out it comes. How do I fix this? There's two options, and then we'll be done. Right there. B minus 1. What's the other way? I equals 1. Is that what you had? There's a third way. Result equals 1 to start with. Ha! There's so many ways. The way that I came up with was right here. B minus 1. We stop one early. We'll pick up on this next week. I think this was valuable. Have a great day, everybody.
Real quick.
Did you hit the post?
Yeah.
Thanks.
Post in HD.
Hey, bud, how's it going?